A key exists to make absence workable. Long before metal teeth met metal pins, security was a human act. Entry was controlled by people who watched doors, recognized faces, and made judgments in real time. This worked when communities were small and boundaries were shared. A doorway wasn't a technical problem, it was a social one. You were let in because someone knew you, trusted you, or decided to trust you for the moment. As buildings grew and ownership separated from presence, that system began to strain. Homes became workplaces. Workplaces became warehouses. Warehouses became networks of rooms that no single person could monitor. The question shifted from who do I know to how do I grant access when I'm not here? That is the problem the key answers, and it answers it by reducing trust to geometry. Early mechanical locks were crude but revealing. Wooden pins dropped into holes. Bars slid into notches. The principle was simple: block movement unless a specific shape intervenes. The key did not prove identity, it satisfied a condition. That distinction matters. A lock does not ask who you are, it asks whether the object you're holding can temporarily reorganize its internal parts. Over time, that internal arrangement became more precise. The reason keys have teeth is not tradition, it's tolerance. A flat blade with a few cuts allows a lock to demand alignment across multiple points at once. Each cut lifts a pin to a height that must be correct simultaneously. Too high or too low, and rotation fails. This is not about cleverness. It's about error margins. Locks are built to reject imprecision, but only just enough to slow the wrong attempt while allowing the right one to feel effortless. That balance shapes everything about a key's form. The metal must be rigid enough to transmit torque without bending, yet soft enough to be cut cheaply and consistently. The profile must be complex enough to create variation, yet simple enough to slide smoothly into a slot by someone who isn't looking closely. The head must be large enough to grip, but not so large that it catches or announces itself. Even the sound, a small scrape, a muted click, is part of the design, confirming success without drawing attention. Keys are also designed around loss. This is often overlooked. A system that assumes perfect retention would fail immediately. People misplace objects. They lend them. They duplicate them without permission. Keys acknowledge this by making replacement easier than prevention. Rekeying exists because locks are not moral systems. They don't punish. They reset. The cost of changing access is meant to be lower than the cost of constant vigilance. This is why keys feel temporary, even when they're old. They carry the expectation that access will change. Ownership will transfer. Trust will be revised. A lock that could never be reconfigured would turn every lost key into a permanent vulnerability. So locks are built with the assumption that they will be altered, and keys are built with the assumption that they will be invalidated. Human behavior also explains why keys require a turning motion. Rotation does two things at once. It verifies alignment and demands intention. Accidental pressure is unlikely to produce smooth rotation. Deliberate movement is required. This makes the act of opening a door both mechanical and psychological. You feel the resistance. You commit. The door doesn't drift open. It yields when asked properly. As environments changed, the limits of keys became more visible. Large institutions needed audit trails. Shared spaces needed revocable access without physical exchange. Keys could not remember who used them or when. They could only be present or absent. Cards, codes, and biometrics emerged to answer those new demands. Yet the physical key persisted, not because it was superior, but because it was sufficient. It requires no power. It fails predictably. It can be understood by touch. That tactile understanding matters. A key communicates its function immediately. The slot invites insertion. The head invites grip. There is no interface to learn. This makes keys resilient in emergencies and across cultures. When systems fail, keys remain legible. That legibility is part of their design success. The most revealing aspect of a key is what it does not do. It does not authenticate you as a person. It does not evaluate intent. It does not adapt. It simply enforces a boundary defined in advance. In doing so, it turns trust into an object that can be carried, transferred, or withdrawn without conversation. That is its quiet power. The aha moment comes when you realize the key is not the security. The lock is not the security. The security is the decision to accept shape over judgment, to allow access based on possession rather than presence. Everything about the key's form follows from that single choice. When you turn a key, you're not proving who you are. You're demonstrating that, for this moment, the system accepts the object you hold as sufficient. The rest, teeth, metal, torque, is just how that agreement is enforced. This is why keys have lasted so long. They solve a problem that doesn't disappear: how to make absence safe enough. Their design fades into the background because it's meant to. When it works, you don't notice it at all. And that is the signature of invisible design, doing something important without asking to be seen.